Hi everyone, in today's video, me, Isaac Yao, together with 4 of my friends, Adichie, Shivan Vijayan, Tan Haoping, and also Muhammad Nazan, will be explaining about non-Newtonian fluids, as per assigned by our lecturer, Dr. T. Lee Hong. Now we will be explaining about non-Newtonian fluids. What are non-Newtonian fluids? Non-Newtonian fluids are fluids which their viscosity can change over time when force is exerted onto it or removed. Basically, if there is a change of force applied to this type of fluid, the viscosity can change. And this type of fluid does not obey Newton's law of viscosity. So Newton's law of viscosity explains that it is the relationship between the shear stress and also shear rate. And this relationship is studied under mechanical stress. So when there's stress or force applied onto it, or even pressure applied onto it, we can understand or we can study the change in the shear stress and also shear rate in the fluid. So this Newton's law of viscosity only happens in fluid, for example, liquid and also gas. So this Newton's law of viscosity helps us to study the ratio. In this case, the ratio of the shear stress and also shear rate, both of these components, will remain the same if we have constant factors, for example, temperature and also pressure. So if these factors change onto different type of fluids, the viscosity changes and also the shear stress or the shear rate will change, giving us different ratio. So this is the equation for the Newton's law of viscosity. We get this. Tau, which is the shear stress, is given by the viscosity multiplied by the change in the speed of the fluid or the speed of flow of fluid divided by the thickness of the fluid. So the change will give us the same equation as this, and later on we get to find the force, in which force is equivalent to the multiplication of the area or the cross-sectional area, for example the tube in which the fluid is flowing, by tau, which is the shear stress. Now I'll be explaining about viscosity. What is viscosity? Viscosity is the measurement of the resistance, or it is the difference in thickness of a particular fluid. So the higher the viscosity, the higher the resistance. Therefore, it is harder for the fluid to flow. So let me give you a scenario here. I have a slope and I pour 2 different fluids. So one fluid flows slower and one fluid flows faster. So you can already tell that based on this scenario, the fluid on the left has higher viscosity and the fluid on the right has lower viscosity because this one flows faster and this one flows slower. Therefore, this fluid is thicker or has higher resistance compared to this. So let's show you an example of a very common non-Newtonian fluid that we can make from our home, which is called Oobleck. So what is Oobleck? Oobleck is the mixture of cornstarch and also water, which is a type of very fine solid and also a very common fluid or common liquid in our case. So with the perfect ratio or a very close ratio of 2 to 1 or 2 to 1.5, we get to make the perfect Oobleck. So let's look closely. This is how the component of the cornstarch looks like, and these are how the molecules of the fluid or the water look like. So you can see here are fine little particles of solid and here are particles of liquid in which it moves around randomly. So after making this Oobleck, here is an example of a bowl. So this is a mixture of the cornstarch and also the water. So you can see the molecules of the mixture. So this is a very common non-Newtonian fluid, or you can call it Oobleck. So now when we apply force to it with very high amount of force, you can see that when you apply very high amount of force, in a very quick manner, you can see that all the cornstarch molecules gather around here, which all the solids gather around here, and the fluid particles can seep through the cornstarch particles or the molecules. Therefore, this part will be solidified and give us a very strong characteristic, and therefore increasing its viscosity in this area or its thickness so that it behaves like a solid. What if we apply very less amount of force at a very slow rate? So you can see here an animation. If you apply very less force, you can see that it behaves like a normal fluid because the solid particles of the cornstarch are very small. So this mixture behaves like a normal fluid. It flows away from your hand. So you can see your hand can be pushed deeper into the solution. So here is an example of a Newtonian fluid. For example, plain water. In our case, you can just see the water molecules, which are shown by all this. So it flows and follows the shape of the container, which is the characteristic of a liquid. So no matter how much force you apply onto this fluid, high amount of force or even very slow rate with small amount of force, it behaves like a liquid. It does not behave like a solid. And this is a Newtonian fluid.
Why honey flows slower than water? So as we all know that honey, I'm going to start. Honey has different viscosity to water. Viscosity is measure of resistance of fluid to flow. Honey is highly viscous with more resistance and flows slower than viscous fluid. How can the flow of honey be increased? Viscosity can be decreased to have higher flow. Viscosity changes with temperature. When heat is introduced, particles have more energy and able to move easily. Impact of increasing temperature reduces cohesive forces, hence increasing the rate of molecular interchange. So yeah, as you can see, it's pretty slow. So yeah, as this proves that honey is more viscous than water. Thank you.
Toothpaste acting as a non-Newtonian fluid. You can't say toothpaste is a solid because solid material have fixed shape, but toothpaste doesn't. Neither can we say it's liquid because it needs a certain force to push it out and in order for it to come out of the tube. So as you can see, when I squeeze the toothpaste out, it comes out, but depending on the shear stress putting into it, if I were to exert a larger amount, the amount of toothpaste which comes out is more. And unlike water or other Newtonian fluids, their viscosity changes depending on how fast they are being sheared, and the viscosity will decrease the faster it flows when it's squeezed, as I've shown earlier. When I squeeze it faster, the viscosity will decrease, therefore being the thicker the liquid will become thinner, and therefore it will come out of the tube faster.
Hi, so today I'll be explaining about the shear thinning effect of a shampoo. So the way I'm going to demonstrate the shear thinning effect of the shampoo is the K effect, is through the K effect. And this effect shows how a shampoo is a non-Newtonian fluid and how it has a shear thinning properties. So you might be wondering, why did this K effect actually happen? A simple explanation will be that the bed of shampoo at the bottom and the shampoo on top flowing actually cause a shear force between each other and thus thinning the shampoo in between, causing it to be less viscous. This allows the shampoo to actually slip off the bed of shampoo at the bottom and actually spurt everywhere because the thinning shampoo in between acts as a lubricant so that it will slip past each other and it starts spurting everywhere. This proves that shampoo is actually a shear thinning fluid and it is a non-Newtonian fluid.
So welcome back everyone, it's Isaac once again. So let me talk you through about how important non-Newtonian fluids are in the industry, the applications of it in the industry. There are many factors, for example, the safety in vehicles, so that this avoids skidding in vehicles. For example, in our driving system, when both our wheels or both our rear wheels are spinning in the same direction at the same speed, this allows the fluid to perform like a normal fluid or liquid in our case, because there are no shear stress acting on the non-Newtonian fluid or the oil in the driving system. However, if one of the wheels or both the wheels are not driving in the same direction or at the same speed, this causes the shear stress to happen into the oil or the non-Newtonian fluid in the driving system or in the differential section. So this allows the driving system to be connected to the front driving system so that the vehicle can perform with all four wheels, allowing better stability, better traction, and also safetiness to prevent the skidding, because all four wheels are connected to the driving system. Other than that, we can talk about safety in suits or in protection. For example, non-Newtonian fluid in bulletproof vests or even shield. This is why non-Newtonian fluids are used in our vests or in our bulletproof vests, because of the flexibility that it can react or act like a fluid or a liquid when we are moving slowly. However, when there is an impact or maybe a bullet shot or a knife stab or even hard punches from external, we will not receive the impact. It will only be received by the non-Newtonian fluid, which will solidify and act like a solid because of its very high viscosity due to the large impact that is exerted on it. Other than that, let's talk about clothing. Why not? Let's talk about shoes. So we can mold or create a design where the sole will have non-Newtonian fluid in it. So when we are stepping on it with at a very slow rate, for example, we will not feel the hardness of the sole. This is because it acts like a liquid. However, if we are stepping on probably a hard surface or very large impacts from the ground, even with hard rocks from the ground, we will not feel the pain because all the impact is absorbed by the non-Newtonian fluid, and the non-Newtonian fluid will taken up, thus increasing its viscosity to absorb the impact. So, do you think non-Newtonian fluids are useful? Do you think it's fun? In the project of Oobleck, as you have seen earlier, are you intrigued to learn more? So that is all from us, from this group. Thank you so much.